Hi everyone, I'm Rosario Catelli from the University of Naples, Federico II, and I'm glad to present you our work, Semantic Management of Enterprise Information System through Ontologies. This is the outline of our work, so we'll see briefly an introduction, state of the art and open problem, then I illustrate to you our proposal and use case, and then the conclusion of our work. To introduce you to the environment in which we set our research, I have to say that we collaborate with the Touchy Rail STS company and in detail with the cyber computer security and assurance control department. So our work was focused on the complexity of the IT environments that augmented the costs and the time needed to deliver the services within a company. And for instance, to verify the security according to the corporate policies and assess them, um, this has become particularly increasingly difficult. And on the other side, enterprise information systems has been stressed because trying to tempting to pursue compliance to standards was needed an enhanced interoperability among all enterprise stakeholders. So we have to find a solution to find accordance within company stakeholders. And in detail, this work was also focuses on another aspect because nowadays cloud governance approaches where can be considered divided into two main approaches that are cloud providers considered as common service providers, and these also mean reduced control on company and services. And on the other side, the cloud aware ethic governance, but with a grave trade-off and a coarse-grained control on the governance. And another problem was related to the fact that a model-based enterprise architecture management approach um, tries to reduce the conflicts among stakeholders, but on the other side, it produces a very intensive work for company workers that are forced to keep updated um, all the documentation within the company, and this is a very not flexible approach. So the main open challenges were related to the main objective of the AIM, that should be to bring the highly distributed knowledge of the contributing stakeholders within the company. And second, business architecture programs need to be approached from a management perspective rather than a modeling perspective to implement a sustainable business strategies. And finally, planning tools should support not only architecture modeling, but also the creation of rollout plans and implementation for continuous improvements over time. So our work was focused on the development of an ontology that can help company workers to produce in a timely manner better works, and in particular revolved to the development of an ontology to support the compliance of the company in front of the ISO standards. So we can introduce the development steps of ontology that can be divided into 7 steps. And as you can see, the first was to determine both the domain and the scope of the ontology, then considering reusing existing ontologies, enumerate important terms in the ontology, define the classes and the class hierarchy, then their properties, phases, and then finally create an instance for every element that you need within. Um, in detail, our proposal was focused on the possibility to address this problem through the building of a domain ontology. And for this, we introduced a mixed approach, leveraging both standards and dictionaries. Was possible to take into consideration all stakeholders' technical and literal point of view, and find a solution um, to mix problems proposed by several company departments. Um, Our methodology suggests some practical suggestions about the refining of the domain ontologies, and then to steps 3 to 6 that we've seen before. A chance not to considered until now consists in leveraging something existing to enumerate important terms in the ontologies. And this was the motivation, because we introduce standards and vocabularies that avoid to us to forget the overview out of our domain, that and strengthen the initial audit activity uh, in the company. So we leveraged ISO and NIST standards for a technical point of view, and the Cambridge Dictionary to solve inconsistencies within the ontology for the literal point of view. Then we produced classes, properties, and hierarchies within the ontology, mixing and matching, then verifying and validating terms, and then we produce the final domain ontology. Why use both standards and dictionaries? The main problem that was using only technical standards is due to their circular definition, because they usually define something referring themselves to something else and so on, until you are at the beginning again. So it's not a practical approach, as we see in the following slides. And while using dictionaries, is also possible to extract the semantic meaning to mix and match what standard says, trying to solve this problem related to the circularity and finding the best atomic definition within the ontology. Our main use case, so remember that our work was set within the environment of the cybersecurity department of Hitachi Rail STS. So we focused on an information security domain, and we built a class around the process high-level concept. So leveraging the ISO 27000 and NIST 1853 standards, we started from the definition of the process concept that was considered like a set of interrelated or interacting activities which transforms inputs into outputs. So for this reason, we include two related operations, receives an input and provides an output as function to our process instance. And after that, we move on the activity concept that ISO, IEEE, and so on define as a set of cohesive tasks of a process. So we were addressed to find out the meaning of the task concept. So what is a task? Here, one of the main problems in the structuring our ontology. As you can see, we have several drawbacks arose because there are at least 3 conflicting definitions. For ISO 15 to 18, a task can be defined like a required, recommended, or permissible action intended to contribute to the achievement of one or more outcomes of a process. Then for another ISO standard, it was considered like a set of activities undertaken in order to achieve a specific goal. And finally, for NIST, it was considered a task is a specific piece of work that combined with other identified tasks composes the work in a specific specialty area or work role. So take in mind this definition, and we try to analyze them one by one to find the more accurate and useful definition of task, to define a better instance of task within the ontology. So the first definition that we analyzed, that you see in the blue rectangle on the left, leverages the concept of action, and unfortunately we don't find any standard. We did not find any standard that define the concept of action, but the Cambridge Dictionary does. It defines the concept of action as the process of doing something, especially when dealing with a problem or difficulty. But this poses a circularity problem, because from the action definition, we go back again to the process definition. And the second point was related to the fact that the concept of outcome of a process poses a question. Is it the same output indicated by the ISO 27000? So for these problems, all these suggested us to overcome this standards definition of task in order to avoid the circularity problem. Then we go to the second definition, analysis, and the definition number 2 is the blue rectangular on the left. But also in this case, the ISO definition creates circularity, because using the already defined activity concept and also the problem related to the definition of the goal problem, we decided to overcome this definition also. The best definition that we found was that of NIST. A task is a specific piece of work that, combined with other identified tasks, composes the work in a specific specialty area or work role. Because this is an enough atomic definition on the one hand, while on the other hand, these give us also a better focus of our ontology that was related to information security domain. So and the boundaries of our ontology imposes us not to go deeper to avoid any lack of focus on the main topic, that is, as I said, information security. So using this definition, we can find the right level of detail and a satisfying trade-off between focus and atomic definition inside the ontology. But we have also to refine the outcome concept. So nonetheless, the concept of action defined by ISO inspired us to search for outcome concept. Our first thought was related to the same concept of process. Its ISO definition assumes quantitative characteristic, promoting a sort of ungluing from the industrial logic where processes are used to create value and not only more object. Next, standards don't define output, outcome, result, and effect, all definitions that we encounter. So we use the Cambridge Dictionary. Output is an amount of something produced by person, machine, factory, country, etc. And this confirmed our first thought was not so wrong. Uh, Outcome instead is a result or effect of an action, situation, event, etc. Result is considered something that happens or exists because of something else. And finally, effect is the result of a particular influence. And all this definition give us the possibility to refine the outcome concept introduced before. And also the goal concept refinement was a little bit tricky because we found a definition of goal in NIST defined as an intended outcome, but clearly it was something missing because if we define goal as an intended outcome and we link this definition inside our ontology, also in this case, we have a problem of circularity. So what about the mixing and matching that we introduced at the beginning? To promote the process to a qualitative and not a quantitative, as we said before, characteristic, we decide to significantly change one of its operations. Provides output became delivers results. And the semantic agreement among all the other concepts was found also adding this definition. The Cambridge dictionary states that a situation is the set of things that are happening and the condition that exists at a particular time and place. And the ISO guide 73 of states that an event is an occurrence or change of a particular set of circumstances. Then verifying and validating the classes hierarchy, we subsequently decide to treat action, situation, and event as an object of type process, while effect was treated as an object of type result. Verifying and validating the ontology, we have to solve some problems related to the term disambiguation. The last problem was about outcome, as we said some minutes ago. Analyzing one of the nodes attached to the definition of event, we were directed through a possible solution. It states that an event without consequence can also be referred to as etc. And because of the node, we have considered a consequence like something with negative connotation, have told the definition of consequence on ISO as effect, change or non-change, usually associated with an event or condition, or with the system, and usually allowed, facilitated, caused, prevented, changed, or contributed by the event, condition, or system. And this definition could be considered neutral, while outcome linked to goal also, or the goal concept that we introduced before, can be considered like something with a positive connotation. So we successfully split these connotations of the outcome concept. And the result can give us the possibility to add two operations to our result class that were the has outcome and the has consequence inherited by that particular result object that is effect that we introduced before. So to sum up, we propose a model that integrates approaches from EAM, IT governance, and cloud computing so as to produce a holistic governance framework that is not a simple task because we have to take in consideration all the point of view of the stakeholders within the company So we sketched out the first step to fill in the gap between the standards views of business IT/OT alignment and governance and security alignment within a cloud environment setting. And we plan in the future to focus on how to refine the model, to focus on semantic aspects and methods, and how to extend the model leveraging COBIT and ideal frameworks. Thank you.